Hello dear student, today's topic is congruent triangle. In today's topic we're going to talk about congruence of the two triangle. What is the congruent of the two triangle? So today we're going to learn how to prove two triangles are congruent. So by using what? Four rules, which is side, 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 side angle, side, and side angle, side, and HL. So what we need today, we need the corresponding angles, corresponding side, and congruent triangles. So we have a quick review about the last lesson. If you remember, we studied some basic things. We said if you have two parallel lines, it create 8 angles. The angles which is they are exactly in the same place, they call corresponding angle, like angle 1 and angle 5, angle 3 and angle 7, angle 2 and angle 6, angle 4 and angle 8. Then we study something else which is called alternate interior angles, which is we said the interior angles, which is they are opposite of each other, like angle 4 and angle 5, angle 6 and angle 3. Then after this one we study another one which is vertical angle. What was the vertical angle? When two lines intersect each other, the opposite angles, this side and this side, they are opposite of each other, they call vertical angle, which is always equal to each other. And this angle and this angle, they are opposite of each other, which is always same measure. Then we study another one which is called same side interior angles, which is we said if you have two parallel line at the angles which is inside the two parallel line, they are exactly the same measure? No. If I plus them, it must be equal to 180. Like 4 and 5, if I plus them, the answer should be equal to 180. Then we can call it same side interior angle. So today we're going to use this rules also to find the two triangles are congruent. So if you take a look to this one, 51, 129, if I plus them equal to 180, it's already showing there. That's why they call these two same side interior angle. So then we have this one it's already called two things. If you take a look, there's a difference between these two triangles. So this one is exactly the same thing, same size, same measure, everything. But take a look to this one, their size is already different. So these two already have two different names. The first one we call it congruent and same, but the second one it's already similar, which is we're going to study this figure in grade 9 and the property of it also we're going to study in grade 9. Then now if you take a look, we have two triangle. In this two triangle, they are exactly the same thing. How we know they are exactly the same thing? Because this side have one line, this one have also one line. So that means this one and this one is already equal to each other. That's why we said AB equal to DE. Then if you take a look, this side have two lines, this one also have two lines. So that means BC is the same length as EF, which is we said here. Then the last one, we have 3 line here, we have 3 line here. So that means the lengths of this one and the lengths of this one, which is AC and DF, are exactly the same thing. That's why we say these two are congruent. And also if you take a look, we already show you the 3D move of the triangle. If you take a look to this one, these two triangles are exactly the same thing. If you move it a little bit, it will go to the other one and it will be exactly the same thing. So how we prove the two triangles are congruent? By 4 rules. What are they? The first one is called side, side, side. The second one is called side angle, side. Then the last, before the last one, is called angle, side, angle. Then we have the last one, which is called HL, which is hypotenuse and one of the legs congruent. And in the number 4, it's always used this one when we have right angle. And we already know what is this sign mean? It's mean congruent. So the first one, if you take a look, what we have the congruence of side, side, side. Before I'm going to explain it how we're going to do this in exams and in quizzes and how we solve in exercise, we need to know what is side-side congruency mean. So if the three sides, he mean the three sides of the one triangle are congruent to the three sides of the another triangle, then the triangle are congruent. So if the first one and the second one have exactly the same measure of the sides, that means they are congruent. So now let's prove it. Let's see. If you take a look, this one is 4, this one also is 4, this one is 6, this one is also 6, this one is 7, this one also is 7. That's why we say these two are congruent. But if you take a look to this one, do I have any number in the sides? No. How many triangles do I have? This one is easy. So I already have 2 triangles. That's the first one. And in denominator we have a second one. So the first one is called PQR. So PQR, the red one. Then the second one is PSR, the blue one. So he said prove these two triangles are congruent. How are we going to prove it? It's actually easy peasy, because I already have one line in the first one and one line in the second one. That means I can say PQ, it's already congruent to PS. That's the first one. How I know this one? Because it's already given. It's already showing there. He already showed me the line on it. So I'm going to write, because it is given, G. It's been given. Then if you take a look, how many lines do I have here? On the blue one, 2 lines. Then in the red one, how many lines do I have in this side? Also 2. So that means in this case I can say QR, it's already congruent to SR. If you said RS also, it's correct. So in this case, what is the reason why these two congruent? Again, because it is given. And guys, you need to know the one more thing. What is it? Which is, if you have a common line, if you take a look, PR is common between the red one and the blue one, this line in the middle. So we call this one reflexive property. So what is a reflexive property? It's a common line between the two parallel, the two triangles. So in this case I can say P or RP congruent to PR. Why? Because it's already reflexive property. By reflexive property, well, I'm going to write all this kind of stuff. No need to write. Done. Because it's reflexive property. Now how many things I found it? I found it a side, then I found it another side, then I found it another side. How many sides did I found it? 3. So in this case I can say the triangle PQR, it's already congruent to triangle PSR. By which rule? Side, side, side. That's how you're going to prove it. Most of the time we bring this question in exams and we only give you the graph. We're going to say this shape is already congruent. By which rule it's congruent? So you're going to say, because I have one side 2, then this side to this side, now I have 2 sides and I have a common side, so that means it's side, side, side. That easy. Then what if I have another question? So if you take a look, we have another question. This one, question number 1. I'm not going to solve it because it's already like the other one. So, but I already going to help you. So this one have one line, this one have one line. So that means DA is equal to BC. Then this one have 2 lines, this one also 2 lines. So BA is equal to CD. Do I have a common line? Yes, BD, DB. So how many lines do I have which is they are already equal to each other? 1 with this one, this one, then that one with this one, then the middle one. How many lines did I found it? How many sides did I found it? How many things I found it? 3 things, which is side, side, side. So in this case it will be side, side, side. Then that's the example that we have in our book. So how are we going to bring this question? I'm going to give you one of those shape and I'm going to say they are congruent, but how they are congruent, by which property they are congruent. So you need to know this one is 4 centimeters, this one is 4 centimeters, this one is 3 centimeters, this one is 3 centimeters. Do I have a common line between them? Yes. So that means it's side, 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 which is easy peasy. Same thing for the other two. Then what if I have a side angle side? What is a side angle side? In side angle side, if the two sides are include angle, one of the triangle, and two sides and include one of angle for the another triangle are exactly the same thing, we can say the two triangle are congruent. What do we mean by this? So if you take a look to this one, this shape, before I'm going to explain it, I'm going to remind you something. We studied something, we said if two lines cut each other, the opposite angles called vertical angle, which is in the book, it will not tell you these two angles are vertical angle. You need to know by yourself. If you see two lines cutting each other, we call it the opposite angles by vertical angle. So let's see this example. Let's see what we have. Now in this example we have two triangle. What is the first one? The first one is NPK. So let's draw a different colors to know how many triangles do I have. That's the first one. Then the second triangle we have LPM. So now how many triangles do I have? Two. So in this one we have two lines. This one also have two lines. So in this case I can say NP is congruent to which one? Don't forget the line. To PM. Why? Because it's already given. He gave me two lines on it. Then I have one line here and I have one line here. So that means LP is congruent to what? To PK. How I know this one also? Again, it's given. Then we already studied something. We said if two lines cut each other. So let's see if we have two lines which is cutting each other or not. So we have the first line and that's the second line. These two lines cutting each other or not? Yes. Then because they cutting each other, that means the angles, which is they are opposite, they are congruent or not? Yes. So how we name this angle? NPK. So I'm going to say NPK angle congruent to LPM. LPM. They are congruent. Why? Because they are vertical angle. Now if you take a look how many things we found it. So let's count how many things we counted. We found it. This side, that's one side. Then we found it angle. Then we found it another side. So it will be side, angle, side. So in this case I can say NPK triangle, not angle, sorry. Triangle is congruent to triangle LPK. LPK. By which rule? Side angle side, which is already here. That's how you're going to solve this question. So let's go to solve another question to understand it better. So in the next question, which is example I think number 3, yeah, he gave me a shape. He said prove that this shape is what? Side angle side. But he gave me the hint. First of all, he said the two lines are bisected, so the diagonals are bisected. So first of all, what is a diagonal? We need to know what is a diagonal mean, okay, and what is a bisected mean. So diagonal, it's already mean when you have a shape like triangle. In the triangle we have two lines inside it, so which is go from angle to the angle, which is called the diagonal. So this line is called diagonals, okay? So these diagonals here, he already gave me a hint. Diagonals, he said the diagonals are bisected. So what does bisected mean? Bisected, it's already mean that two lines that we have, they cut each other to two equal parts. So that means this side is already equal to this side equal to this. So that means if this one is 2, this one also will be 2. If this one is 4, this one also is 4. That's why it's called bisected. That's the real meaning of bisected. So now, because I already know this one, he said the line are bisected, so that means I already explained this one. I said that they are. That's the real meaning of the bisected. So now, in this case, because he said JHLK is bisected, so that means this side equal to this. Only because of this writing here, I know these two are equal. Then this one also equal to this. So in this case, it will be easy to prove this one. Why? Because I already know G is congruent to what? It's equal to GL. Then why? Because it's already, you can say given, or because you can say bisected. You can say because it's bisected or given. Both of them are exactly the same thing. Next one, HG is congruent to GKY. Again, you can say because it's bisected or given. Then we already studied something. We said if the two lines cutting each other and the opposite angles, it's already called vertical angle. So this angle and this angle, they are called vertical angle. So JGK angle is congruent to HGL. Why? Because they are vertical angle. So if this one is vertical angle, and we already know the two sides are congruent, so I found it a side, then an angle. If I go, so this side and this side, then this angle, then this side. How I think I found it? The two sides on one angle, and they are in order. So in this case, I can say the two triangle JGK, which is given here, is congruent to triangle LGK. Why? Because we already proved the side equal to the other side, then the angles are congruent, then the other angle also congruent. So that means the two triangles are already congruent by side angle side. So that's side angle side. So the next one that we need to know is angle side angle. So before I'm going to explain this one, it's the easiest one. We need to know what is these two dots mean. What if I have the line instead of the dots? So let's say what if I have a line like this? So let me change the color. Okay, so if you have a line or a dot, that means they are congruent. If this one is 10, this one also will be 10. Why? Because he did two dots here. Then what if it's a line? A line is exactly the same thing. If this one is 10, this one also will be 10, because by this two line he tell me the angle are congruent. Then what is this? This one is angle 90. So we already know if this one is 90, this one also will be 90. So that means it's already easy. If I have something like this, how I'm going to prove the two triangles are congruent? In this case, I already know that's the first one. That's the first triangle. Then the second triangle, what is it? It's the black one. So I'm not going to change the color. Red and black, we count it like this, okay? So now, if I want to solve it, what I'm going to do? I'm going to say, because WXV, that means this angle here. WXV is congruent to, which one has a dot also like this here? What is the name of this angle? I can call it VXU or UXV. So the most important thing is the angle that I need, it must be between the two letters. So UXV. So UXV. Why these two angles are congruent? Because it's already given. Then, do I have a common line between the two triangles? Yes. So if you take a look, XV is congruent to VX. Some people say XV again, which is exactly the same thing, correct? So this one, why? By which rule? Reflexive property. So this one is congruent by reflexive property, these two lines. Then what about this one? If this one 90, this one also will be 90. So WVX. So WVX is already congruent to, it's an angle, equal to XVU. XVU, or you can say UVX, same thing, angle. Why? Because it's already, again, given. So now that means I proved the two triangles are congruent. How? Because I found an angle, a side, and another angle. So that means in this case I can say this two triangle, which is triangle UVX, is congruent to VUX, or UVX is same thing, congruent to WVX. By which rule? Angle, side, angle. So that's how you're going to find angle, side, angle. So the next one is, I will give you a question like this. So how are you going to say these two are congruent? I already give you two angles and you have a common line. So that means it's angle, side, angle. What about this one, which is a little bit tricky? This one is the trickiest one. We already studied in the last lesson. We said if you have two parallel lines, that means the opposite angles will be alternate interior angle. That means this side equal to this side, this one equal to this one. I already know this one equal to this one. So angle X and angle T, they are congruent. Angle F and angle D, they are congruent. Then Fx is congruent to TD. So that means this one also will be angle, side, angle, which is also easy. Now the next question that we have, the next example that we have, which is the last one, which is called hypotenuse, and one of the leg, which is, we call it HL. This one is the easiest one, and many people have a problem with it, but it's actually easiest one. So if you find out one of the leg are congruent and they have same hypotenuse, then in this case you can say the two triangles are congruent. What do we mean by this? Guys, before I'm going to explain this topic, we need to know the part of the triangle. I want you to you must remember this one. When we can use HL congruency, if you have right angle. If you don't have right angle, you cannot say the two triangles are congruent by HL. So do I have right angle? Yes. Then this side of right angle, it's called leg. This side also is called leg. The opposite of the right angle, it's called hypotenuse. So this one is called hypotenuse. Okay, so if I want to solve this question, if I want to solve it, first of all I need to know the parts of it. So let's solve. Now let me zoom this one. Okay, then we start solving. Now how many triangles do I have? I have many triangles actually. 1, 2, 3, 4. So you can divide it 2, 1, 2, 1, 2, then 3. So it's actually 5 or something like this. So now, but I only need 2 of them. The book asked me to prove this one, which is I drew it in red, which is my drawing is not good. It's congruent, which is we have in black. I'm not going to draw anything on it. So this one is actually easy. Why? Because I'm going to check. Do I have right angle? Yes. In both of them? Yes. Do I have a common side? Yes. Do I have same hypotenuse? Yes. We said the opposite of right angle is called hypotenuse. So this side is hypotenuse. So if I have same hypotenuse, can I say it's HL? Yes. if I ask you to show your step, how are you going to do this? You're going to say, because WVX, where's WVX? This angle is congruent to WYX. WYX. How I know these two are congruent? Because it's already given, both of them are angle 90. Then that's the first one. Second one, I'm going to say VW is congruent to YX. Why? Because again it is given, that's why I'm going to write only G instead of given. Okay. Then XW is equal to WX. This one is already clear because XW is common between this triangle and this triangle, which is called reflexive property. By reflexive property, this one is called common line. Now, do I have right angle? Yes. Do I have common line? Yes. Do I have same hypotenuse? Yes. So that means this one is HL. That's how you're going to solve these questions. So the next question that we have. So the next one that we have, it's exercise questions, and that's the note. The number 4 is only used for right angle. We need to be careful about this one. So if you take a look to this one, example number 6, maybe we're going to bring a question like this. We will say, prove these two triangles are congruent. So, or these two triangles are congruent by which property? So you need to choose side, 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 angle, side, angle, side, angle, side, or HL. So first of all, if you have right angle, the first thing that coming to your mind is HL. Why? Because you have right angle. Do I have a common line? Yes. If you take a look, we said the opposite of right angle, it's called what? Hypotenuse. If you have a common hypotenuse, no need to think about it. It's already HL. Take a look to this one. That's a hypotenuse. And this one is hypotenuse. If you take a look, I have one line on it. This one also have one line on it. Do I have a right angle? Yes. Do I have a common hypotenuse? Yes. So that means it's already HL. That's how you're going to find HL. So if you take a look to those questions, now he asks you to prove each of them. This one only by looking, I know it's angle, side, angle, because two angle is given. So this one is angle, side, angle. So this one is say use HL to prove these two are congruent. Or he say if it is possible, use, or then use the other one. Use HL if it's possible. If it's not, use the other one, another one. Okay. So in this question, this one is HL. Why? Because opposite of the right angle, we have a common line, which is called hypotenuse. So we already said if you have a common hypotenuse, it's HL. But take a look to this one. Can I say it's a common? No, because I don't know if CL equal to BL. I don't know this one, but I know something else. If two lines cut each other, the opposite angles will be exactly the same measure. So good, because I know this one. In this case, I can say this angle and this angle are exactly the same thing. So how many angles do I have now? N to D, then NLB to CLD, this and this one. Then I have common line or not? Yes. So in this case it will be angle, side, angle. So that's how you're going to find each of them. And I think that's the last question, though I'm not going to solve anymore because the other question is exactly the same thing. Yeah, you need to find it by yourself. So that's the end of the lesson. See you in the next class, and bye bye.